When we're trying to do crosses and determine recombination frequencies, one of the things that we have to be able to do is we have to be able to identify the recombinant offspring. Now, typically, we are looking at a heterozygous individual for 2 genes, and we're crossing that with something that is recessive for both. So based on these example genes that I've given you, this heterozygous one will be straight and black, and this one over here will be curly and white. All right, so if we were going to cross this one, this is really the one that we're investigating here because we don't know what kind of gametes would be made from that one. But just looking at the possibilities, we know that that one could generate this gamete, it could generate this gamete, it could be this, or it could be this. Now, starting off, if we're talking about, okay, which ones are the recombinant gametes? Well, you might automatically think it's going to be this one and it's going to be this one. Those would be the recombinant ones. And that might be the case, but it's not necessarily always going to be the case. So, for example, to tell you or show you what I'm talking about, we have to consider where this individual actually came from or how it was generated. So this is the product of 2 parents being crossed, and it could have been parents like this. If that were the case, this parent would have contributed capital A, capital B, and this one would have given little a, little b. Okay, and then definitely these would be the recombinant ones, if that was the case. However, it's not necessarily the case. So another alternative possibility is that the parents that generated that one might have been like this. And if that was the case, this one would contribute a big A, little b, and this one over here would contribute this right here. And if that was the case, this green example, then this one and this one would be the recombinants. Okay, so what I'm saying here is that it's really difficult to determine which ones are the recombinants just based on the looks of the offspring, because typically we're not really given the information as far as which one of these 2 possibilities, this or this, was used to generate that one that we're actually crossing. So what we want to do when we're looking at which ones are the recombinant offspring, we really want to always look for the ones that are present in the lowest numbers. So if we notice, if we're looking at these offspring, and these down here, they are quite variable in number, so they're not equal numbers, then we want to look for the lowest. Okay, so which ones occur in the smallest amounts? The ones that are in the smallest amounts, they will be the recombinant ones. And I'm just going to put it right here, recombinant, like that. The recombinant ones are always going to be the lower ones. The higher numbers are always going to be the parental ones. And that is really the easiest way to determine which offspring are going to be the recombinants. I wouldn't look at all at the appearances of them and the looks, because again, we really don't have the information to go back that previous generation and determine specifically what that actual combination was. Okay, so always look for the lowest ones, then that will tell you which ones are the recombinants, and then you should be able to calculate the recombination frequency based on that.